Okay, which one of the following expressions has an even integer value for all integers a and c? Okay, now one thing that you can count on with even integers, which is going to help you in this problem, is if you multiply an even number by anything, it will still be even. For example, an even number 2 times another even number gives me an even number. An even number 2 times an odd number also gives me an even number. So if we're multiplying an even number by another even number, it's still even. But if you multiply by an odd number, it's also still even. If we look at multiplying by an odd number, 3 times an even number obviously is even, but 3 times an odd number is odd. So we see that multiplying an odd by an odd creates a problem for us. Now, as far as addition is concerned, you can add two even numbers together to get an even number, and you can add two odd numbers together to get an even number. But if you add an even number to an odd number, you get an odd number. And so kind of just by knowing, I guess you say rules, if you will, as far as what happens when you add or multiply numbers together to evens and odds and what you get in return, that's good to know. And that'll help you kind of as you're assessing this to see which one maybe is going to be right. And then you could always test it using numbers for A and C and see if you get the result you want. Remember that you're saying which one of these can work for all integers. So if you find one example that works, that doesn't necessarily mean it works all the time. So you are actually looking for ways to show that they don't work. And that'll help you eliminate options if you're going to go that route. Alright, so let's look at these. We've got 8a plus 2ac. Now, just based on what I talked about before, 8's an even number. So 8 times anything will still be even. 2's an even number. 2 times anything will still be even. So I'm going to have an even number plus an even number on A, no matter what. And if you have an even number plus another even number, you'll always get an even number. 2 plus 4 is 6. 10 plus 12 is 22. They're all going to be even numbers. And so no matter what A and C are, and when I multiply by 8 and when I multiply by 2, I'm guaranteeing that they'll be even. And then when they're both even, adding them together will keep it even. And so I know that A has to have an even integer value for all integers A and C. Now let's pick apart the other ones. Why do the other ones not work? We got lucky that A was the correct answer and we didn't have to technically look at the rest, but let's go ahead and do it just to make sure that you get it. So let's look at B. 3a plus 3c. Now when you multiply by an odd number, an odd times an odd is an odd. An odd times an even is an even. And then depending on if you've got two odds or two evens or an odd and an even, when you add them together, you could get different results. So B is one of those that, yeah, you probably could get an answer that fits the even value at the end, but you're probably not going to always get one. So what if I took an odd number, that 3, and multiplied it by an even number, 2? So let's say that A is 2. 3 times 2 would be 6. Plus 3C. What if C was an odd number? Let's say 3. So A is 2 and C is 3. 3 times 3 is 9. 6 plus 9 is 15. That's an odd number. I wanted an even number, so there's at least one answer that doesn't work for B. So adding an odd and an even together will get you an odd. So is there a way to make 3a odd while 3c is even? Or is there a way to make 3a even while 3c is odd? And yes, there is. You can multiply by one even number and one odd number, and that's exactly what happens. So B is out. C, 2a plus c. Same kind of idea again. Let's say that 2a is 2 times anything is going to be even. So it doesn't matter what we pick. This is going to be an even number. So 2 times 3 would be 6. 2 times 4 would be 8. 2 times 5 would be 10. It's going to be an even number no matter what. But what if C is an odd number? Because it has to work for all integers, even and odd. So what if C was an odd number like 3? 6 plus 3 is 9. That's an odd result. We don't like that. C's out as well. Okay, now let's go to D. A plus 2C. That's the exact same idea behind C. We're not going to redo it. Again, 2C is going to be even no matter what. So if I add an odd number to that, it'll still be odd. D's out. And then E. A times C plus A squared. Now, again, this could go back and forth. Depending on what you picked, you could get one that works. But basically, I need one of these to be odd and one of them to be even. And if I can make one of them odd and one of them even, adding them together will give me an odd result. So, to multiply numbers together to get an odd result, they both would have to be odd. So, what if we picked 3 times 5? 3 times 5 is 15. Now, a squared means that number times itself. So if a was 3, 3 squared would be 9. So what we've got here is a situation where we've got an odd and another odd, which actually that gives me an even result because we've got two odds which add together to get an even. So that actually worked for what we were wanting. So we're looking for a situation that would make E potentially not work. So we've got to think outside the box and try to think of a way to make that not work. Let's see. Okay, what if we changed C instead of it being an odd? Because we need one. We know that any number squared is going to end up being is going to be required for A. So what if we change C to be like, say, 2? 3 times 2 is 6. And then we still have A squared, which is 3 times 3, which is 9. 6 plus 9. That gives me 15. That'll work. So sometimes you try an example and you're like, hey, it does what I thought it would do. And again, remember, that's just one example. So think about every option. Is there any possible way to have it not be true? And so we're looking for one that would have an even integer no matter what for all integers. And while it did work for one on that last one, it didn't work for everything. So can you manipulate it? Can you find a way that would make it not do what you say? And if you can, you have to cross it out, which is good because we already thought A was correct, and we can't have two correct ones there.